So hi everybody, this is Simon alias the new MacGyver. No, that was only a joke. I'm Simon alias the nerd of algorithms, and before beginning, let's position this external microphone and test a little bit how it will be this professional fashion. The footages which, as I mentioned them, will accompany the book, but it can already, in an experimental setting, accompany also the just yet paper mid-length EC that I wrote. It's not completely ready, but almost, on nonlinear dynamical systems. And well, let's put the mic, let's put a weight on it. Okay, close up. Now, okay, it's all connected. Now we can start practically again by introducing what I'm going to do here. Sorry if I listen to some music, but it's morning time, so we need to get on the lanes. If already an EC, mid-length EC, proposes some lab tests, simple or some more complicated, like MacGyver style experiments to do in an electronics laboratory or with mechanical devices, well, let alone how much focus this active part by the side of the reader, longer piece of work would propose. Lots of these experiments. The coolest thing of this is that some experiments do not need any costly equipment. No costly function generators, no delicate and sometimes even costly oscilloscopes. There are some, at least a couple, of experiments that one can do with basic equipment. One of the dynamical systems, if we can call it so, which exhibit even to a naive eye heavy nonlinearity, avalanche-like phenomenon, is scintillation. Okay, and I constructed one of these already, which you will see the same device with a high-definition camera, with a future professional cameraman, but with similar distance recorded sound, all high quality. And well, this is a gas turner which uses scintillation to turn on the gas, to let it catch fire. Now this was modified in order to localize more the 2 points where from one to the other the scintillation goes, the avalanche. This is the positively charged one, this is the negatively, that's why I signed it with a red label. Okay. The scintillation happens because there is the rupture, the breakdown of the dielectric of material, which is air. Also solid materials can break, and it can happen with capacitors under too high potential difference, tension is applied to its two poles higher than the limit one which the constructor sets. Then there is a rupture like this in the dielectric solid material between the two plates of the capacitor, and a hole creates, and so the capacity changes, and so the capacitor breaks down. It can also internally deform, so actually break. But air, since there is enough air, air doesn't, because air is well, now this is a very cheap experiment. This costs like €2, €1, and one can do this, and it would be interesting, and we'll try to present a slow motion record of this under magnification lens and everything. Now, I will also present now how I constructed this, the soldering and everything. So, in order to make this video longer and more interesting. The other thing is, this is a marvelous device of 40 years ago. One of the heavily nonlinear systems is a Schmitt Trigger, or a circuit that creates random or one direction or the other, random, but so that it saturates. Okay, since it's morning, let's try it with an orange. Now, in this device, you will notice that it was not equipped with Schmitt Trigger, and sometimes it gets into confusion. It turns right, left, because it doesn't know there isn't a circuit to bring into saturation the first signal, whether above a certain threshold or below. But this is a good example. Look. Look. Ah, did you see it? It started to turn one sense, then rapidly changed mind. Take one of these, or construct a circuit, a random generator, attach to it a Schmitt Trigger, and see how better it will work. Even because this undecision situations can lubricate, can damage easily, or reduce the half-life, the lifetime, sorry, of the electric engine in it, because these very rapid changes too strong magnetic field creates among the wires of the bobbin, and the Lorentz force like stretches or pushes away from each other the wires, and so the bobbin can damage. So Schmitt Trigger, and try it would this has lasted 40 years. This is a very good product, but it could be even more long-lasting if there were not just a Schmitt Trigger attached before the output to the electric engine, whatever, but also a slow bring-up circuit, for example with a capacitor or something, to let it start slowly and pass to regime a bit slowly, because these rapid movements for the engine look great, not only in that way, but the wheels, those teethed wheels in the mechanism, as teeth of those pulleys turn, if not perfectly grazed, small collisions can happen, and that's not good, because it can break. Okay, have you seen? Go to next recording. We have done everything. Bye bye, and let's go to the recording of how to construct this. By the way, keep this away from an oscilloscope, because these tensions can break it. Never attach an oscilloscope to this or any fine electronics. Keep this out. This is a high energy physics, so to speak, experiment. So just